So in today's agenda, we will be seeing how important it is to monitor a web application and identify any performance bottleneck before an end user complaint. We will be discussing on how to identify application response time and user satisfaction. And to one, let know there was an issue in a transaction because of a bad code or database query by analyzing the error traces. With this, let's take a simple web application architecture. As you can see in this picture, web server like Apache, app components such as Java, .NET, and database, various type of database might be used to run a successful web application. Administrator may use different monitoring solution to monitor these components such as physical server, virtual environment, database, web server, etc. But in today's session, we will be focusing on monitoring your application behavior end to end. So let's discuss on few reasons which cause slowness in the web application performance. Like web server is overloaded with too many requests from the client. Applications developed on a test environment with small data sets seem to operate smoothly, but once it is rolled out to production, you will see the database grows over time and may cause slice of death in the database. Likewise, improper memory and thread management may lead to performance issue. Even recent research studies indicated that if the pages are not loading properly, there are chances that user may abandon that website or search and move on to the next search or website. So we are going to discuss on key metrics like response time, Apdex score, which are more widely and important metrics used across the globe. For example, let's say your testing team complains about high response time. At that moment, your team may think there could be an issue with the network. And this is more common, blame game in the IT team. So let's say an example, your testing team came up with an issue where the application is very slow. The first and foremost thing would be to check with the network team if there is a problem in the network. But most of the time, or maybe there are certain times where there is an issue with the application itself. So monitoring the application is an important aspect in any IT infrastructure. And this will help the DevOps team to analyze and rectify if there is any issue in the code level. So, and also because application might be slow because of query running in infinite loop due to bad code, finding and analyzing this code will help to identify the issue and rectify it. So APM Insight solution supports end-to-end visibility for the web application built on technologies like Java and .NET and Ruby on Rails. In future, we are going to support application for PHP and Node.js as well. So let's see about the APM Insight architecture. The APM Insight agent is deployed on the machine where your app server or web servers are running. So the agent hooks up with the application server process and then sends the information to the application manager. And in the dashboard, you will be able to see various metrics to identify any performance bottleneck. So, for example, the .NET agent where your ISO is running, we need to install the agent there. If it is a Java-based, we support Tomcat, Apache, Web Server, WebLogic, etc., JBoss, Wildfly. So once it is deployed, using the bytecode instrumentation method, the agent will collect the data and push the information to Applications Manager. APM Insight provides a whole new dimension of your web application performance and deeper insight to optimize your web application. And this can be identified or optimized by finding any performance bottleneck like exceptions and identify the slow queries and address those inefficiencies and then speed up your application performance. So once the data is started collected, the anomalies can be detected. APM Insight automatically captures transaction snapshot, and on a single pane of glass, you will be able to see and correlate between application behavior and performance stats. So thus enabling you to quickly identify the root cause of an issue and visualize which transactions are affected and ensure to provide flawless customer experience. The Apdex score, which is Application Performance Index, is an open standard to measure user satisfaction, regarding a web application. It is a metric that provides a single score ranging between 0 and 1, where 0 represents no user satisfied and 1 represents all users satisfied. So this gives business application owners an insight into the measure of their customer happiness and satisfaction level. So if you are building a software application, big or small, your user who uses the application are the lifeblood. So understanding the impact of performance on user satisfaction and retention is a crucial part of building a successful business. The average response time, which is the most widely used metric of performance, and it is simply a direct measure of how long it takes to process a request. Whereas throughput, it is a straightforward count of the number of requests that the application can process within a defined time interval. So understanding how much traffic your application receives can be useful to correlate to other application performance metric to understand the dynamic of how your application scales. The more requests users send to the application, the higher the load would be, right? Similarly, it is important to identify which transactions are slowing down. You know that the application is slow, but you want to identify which transaction, which web page has that problem. So with the help of APM Insight, we are going to capture those information. So one can see the slow transactions which are based on response time. This slow transaction requires attention so that the performance tuning or error fixing can be done. A business transaction is made up of all the required services within your environment that are called upon to fulfill and deliver a response to a user-initiated request. Example like login, search, checkout, etc. This will invoke various applications at the background, for example, web services, third-party APIs, and database. So business transaction reflects the logical way user interact with your applications. And again, it is important to monitor the other components, but we are going to focus on the application performance based on the transaction. Not only that, even the transaction can be broken down with the request or components, and based on that, the APM Insight module give a visibility to troubleshoot where the exact problem is. With this, let me switch to the present product UI and show you the various metrics that we discussed so far. The one which you see now, it is the web page of Applications Manager, where you can download the APM Insight agent for Java, .NET, and Ruby on Rails. So these three agents are available. You can download it. If you're going to download the Java agent, it is just going to be a zip file. You need to extract it in your folder in the machine that you are downloading. The APM Insight .NET agent, it is an installation file, so you need to install where your IS server is running. Now, let me show you the APM Insight agent, which I have downloaded in my machine. So here I have extracted the APM Insight agent. This is a jar file which talks to the application server. And we have the APM Insight conf file where we need to enter details such as the applications manager, host, port, and other configuration pertaining to the application performance, how it should collect the data, like transaction, background application, etc. So those information or configuration needs to be done in this file. Once this is done and saved, we need to point this directory, APM Insight jar file, to your app server. For this, let me open up the Tomcat configuration. It's on my other screen. Let me bring here. So as you can see, the Tomcat application. So if you have installed as a service, you just need to go to the Java tab and add the line here at the end. So you need to mention the APM Insight jar file, the exact directory, and save it, and then restart the Tomcat server. So as soon as you restart, the agent will talk to the app server, collect the data, and send it to Applications Manager. Likewise, we have for .NET as well. So .NET, as I mentioned, you need to install where your IS server is running. So let me show that window and show you various options that we have there. So as you can see, this is our .NET agent configuration page, and you need to enter the host name and IP port. There are other options like you can capture the database SQL query, you can have an option where you can filter the apps. We can have an option where you can enter the proxy authentication, etc. So let me close this window and go to the product UI. As you can see, this view is called as category view, and we have 100+ application components that can be monitored within Applications Manager, and we have categorized them based upon their functionality. So on the left hand side, you can see we have various application server, and in the middle you can see we have database servers, where we are monitoring around 15+ database server types. Likewise, on the right hand side, we have server category, virtualization, we have cloud apps like Amazon, Azure, Office 365 that you can monitor. Likewise, we have middleware and ERP solutions that can be monitored within this tool. Now, let me click on the APM Insight tab, and this is going to take us to the application that is running. So this is my application, a sample Java-based applications that has been configured in our test machine. And the one which you see right now is overview page of the APM Insight. So it shows a dashboard with the recent data that has been collected, the Apdex score, average response time, and throughput. Likewise, we have the web transaction, database, background, and trace tabs, various tabs that you see. And we are going to discuss more on what are all the metrics that we can see here. So for your information, the Java-based APM Insight can be configured for applications that are running on Linux-based machines. With this, let me switch back to the presentation and move on to our next topic. So coming to a third topic of today's agenda, we will be looking more at the database queries and different metrics that needs to be monitored in the database server. Enterprise application rely on multiple components that interact in complicated and sometimes unpredictable way. So these additional layers make it difficult to isolate the root cause when a problem occurs. So it is important to monitor the query, because if you take any web application, most of the web applications are database related. So it is important to understand the number of hits on a particular table. Is there any table that needs to be fixed? Do we need to fine tune the database itself? So these are all various metrics that one should monitor. In APM Insight, we're going to show you the query that are getting executed along with its response time and which operation that query was called. So we are going to drill down to code level and analyze if there is an issue in the methods, if there is an error in the web page. So monitoring the performance and individual call of web application with its response time is important aspect in monitoring the application performance. We can also find the most executed database operation and its response time, DB operation, operations by caller, and the most performed SQL operation on the table. Apart from this, there are chances that the database server might be used for other application or tasks. So it is important to monitor the database server itself, which will help the database administrator to tackle any performance issue. Not only database administrator, I would say DevOps team can also keep an eye on few of the attributes which are important to run their application successfully. So let me switch to the product UI and discuss the database metrics that we are showing. So in the overview tab, if I scroll down, we have in the dashboard, we have recent slow transaction, errors, and response time. I'm going to touch this part in later stage. Now let me click on the web transaction tab that we have. And here we are going to show you the various transactions that took place in that particular instant and what is the response time of that particular transaction. We can even sort it by slowest average response time, throughput, or most time consuming, or errors. So with this also we can filter it out. So in case if you just want to understand the error that has happened in web application or the transaction, we can able to filter it out. So likewise, we can click on the web page, the transaction that took time, and on the right hand side we have component splitter. So this will show you the component that took this web page most of the resources. Likewise, we can drill down to the trace of this information. In the database tab, when I click on the database tab, it is going to take us to the next page where we are going to show you the queries that are getting executed. And again, we have sort by option where you can sort it using average response time, throughput, most time consuming, or errors. And on the right hand side, we're going to show you the overall database response time by operation that has been called, and throughput. And when we click on the individual query, you can get the database operation by caller, which means which page that query was called is obtained and the number of request count it got hit. So we can identify, okay, this query is taking, more users are requesting. So is there any problem? We can drill down. If yes, we can fine tune the query itself. With this, let me switch back to the presentation and move on to our next topic. Now, we discussed a few issues like there is a problem in the method or the query which has called, but it is also important to monitor the database server itself. So now let's discuss few common problems like slow response, problem in retrieving data, and key metrics that one should monitor to avoid this issue. The reason is, even if the code is good or the query is fine, sometimes it is database server which may cause some issues, and in turn performance of application may hit. So we are going to discuss two scenarios here, a very common scenario, but what are all the different metrics that can be monitored within the tool in order to ensure better performance of your application and database server. So slow response from a database server could be because of not enough resource or queries taking more time to execute. So now let's see what are all the metrics one can monitor to keep tab on resource and queries. So we have a buffer hit ratio. The buffer cache hit ratio counter represents how often SQL Server is able to find the data page in its buffer cache when a query needs a data page. The higher this number, the better would be, because it means SQL Server was able to get data for queries out of memory instead of reading it from the disk. The page life expectancy counter measures how long pages stay in the buffer cache in seconds. The longer a page stays in memory, the more likely SQL Server will not need to read from disk to resolve query. Cache hit ratio. This performance metric measures how much the planned cache is being used. A high percentage here means that your SQL Server is not building a new plan for every query it is executing. So it is working effectively and efficiently. A low percentage here means that for some reason the SQL Server is doing more work than it needs to. And it is important to keep tab on these plan hit ratio and buffer hit ratio. When you create a database in SQL Server, data file and transaction log files are automatically created. The data file holds the data and objects such as table, index, stored procedure, and views. The transaction log file records all transaction and the database modifications made by each transaction. So transaction log file contain the information that is required to recover all transaction in the database. So sometimes, like if you go and talk to the database admin team, they will say that I have full recovery mode option enabled. So when you do that, all transactions that take place in the database is recorded in the transaction log file. So it is important to keep an eye on data and log file size. Now let's assume that there is a problem in the application. It is very slow. There are scenarios that there are no enough disk space to write the log and data file. So if that is the case, you will be able to monitor those metrics. For example, disk information from the server itself, or if you associate a threshold for data file or log file, and if you get alerted, there is an option where you can automatically clean that space based upon the script or the command that you have. So that feature is also available in Applications Manager. I'm going to talk about that as well as an example in later stage. So in Oracle database, it consists of one or more logical storage unit called tablespaces, which collectively store all the database's data. Each tablespace in an Oracle database consists of one or more files called data files, which are physical structure that conform to the operating system in which Oracle database is running. Hence, monitoring the used and free byte along with read and write and data file auto extend, which means you can set a table space to automatically extend itself by a specified amount when it reaches its size limit. So these are few key metrics one needs to be monitored in Oracle database. And there are scenarios where you may encounter high CPU usage, which is a common problem in SQL Server. Any query with a bad query plan can steal high CPU time and harm system response time. Likewise, it is important to identify the query which is taking more time to execute. So a database admin not only can monitor the average CPU time, but also can get the actual query that are taking more time to execute. Likewise, we have an option where you will be able to monitor the slow running queries and you can fetch the exact query that is taking time. And based on that, we can configure the threshold and action, and the end user or the respective team can get alerted. Likewise, in Oracle Database Server, when Oracle requires a data block, it first checks to see if this data block is already in memory, that is the database buffer cache. If the data block is found there, Oracle will read it from that place. So this process is called as buffer get. The other process we have is that disk read. So if the data block is not found, Oracle will need to bring the data block from the disk into buffer cache first. So this process is called as disk read. So Oracle, from Oracle database standpoint, the buffer get is logical I/O, while disk read is physical I/O. So a buffer get may or may not require a disk read, but high disk read can cause, high buffer read can cause high disk read as well, which cause input-output workload increase or I/O path bottleneck. So when accessing a table with a large amount of data or database buffer cache with insufficient size or combination of both, the SQL statement with higher buffer gets will also have high disk read, because not all data blocks will be able to fit in database buffer cache and need to swap out to the disk as well. So it is important to monitor these metrics. Now let me switch to the product presentation and show you a few metrics that we have. So let me click on the monitors tab and open MS SQL Server and Oracle SQL Server in a separate tab for me to toggle between the tabs easily and show you the differences. So right now I'm in the overview tab of MS SQL Server. So as you can see, we have various tabs, but we are going to discuss few which is pertaining to application performance. So under overview, we are showing you the availability, buffer cache hit ratio, planned hit ratio, and under that there are various other metrics that one can monitor. For example, total memory, buffer hit ratio. We have other information or attributes as well that can be monitored, but it is pertaining to database administrator and they can configure if they want to. Now let's go to the second tab, which is performance. Here we have other features like various options that you can click and pull out the data. So the first one with the first scenario is top queries by CPU. So when we click, we'll be able to understand the average CPU core, the time it took to execute. Even we have an option where you can use filter by to select the database of your choice. And you can also get, with respect to database, individual database, the query that is stealing the high CPU. So if I scroll down, we can get the top queries by CPU along with the exact query that is running and the database name where that query is getting executed. And with this, we can able to understand the average CPU and average execution time. If it is higher the threshold, then one should need to check this query and fine tune it. Similarly, we have top slow running queries. So when I click on the top slow running queries, again, we have an option where we can filter it by using the last call time or based upon the dynamic values. And we can select or see the query that is getting executed and that are slow, very slow. And based upon the SLA that you have, you can define the threshold and associate with this attribute and get notified for average execution or minimum time execution. So this will help you to identify slow running application in terms of database. Now coming to the database tab, we have the various database that are getting executed. will be shown here, and pertaining to that data log file and the transaction log file will be recorded for you to troubleshoot. Now let me switch to the other tab where we have the Oracle database, and again here we are able to show you the availability of the database size, free space available, and if I scroll down I have option where I can monitor the hit ratios, which is important metric, I would say. Now based on this we can understand how whether your Oracle database is hitting the cache properly or not. Similarly, under query we have buffer get, the top 10 queries we are fetching, and we are showing you the exact query that are getting executed for buffer get. So in case if this query is getting executed a whole lot of time, then we need to verify whether it is also getting executed and taking the data out of the disk, so which will obviously increase the IO output in the disk. Similarly, we have disk read, so where we also, again here also we show you the exact query and disk read per execution and how many times that query has been read from the disk. So this will help you out in identifying the query itself that are causing slowness, and in case if this query is being used in your application or the database server that you are using for your application, you can able to troubleshoot from here itself, or ask the database admin either to pump up the resource, or the DevOps team can fine tune the application. Now let me switch back to the presentation. So now we are going to discuss the second scenario where we are unable to retrieve the data while accessing a record in a web application. So when you try to input a data, you may either get an error or bad gateway error, etc. But there are certain scenarios where at the background the database might be busy. So we are going to see that background matrices that one needs to be monitored. So in the first scenario, the database is able to show the result of a request, but it is taking time to process it. In this scenario, we are going to see metrics that can cause to identify any blockage. So we'll be discussing on session, wait, lock, and block queries. So these four topics we are going to discuss. So with this, let's start with the SQL Server. A SQL session is an occurrence of a user interacting with a relational database through the use of SQL command. So when a user initially connects to the database, a session is established. It is important to monitor the number of connection per host as well as the process ID that are consuming more memory or CPU. When locks are held for a long period of time, they cause blocking, which means one process has to wait for the other process to finish with the data and release the lock before the second process can continue. So identifying blocked session is an important metric, and if needed, one can kill the session directly from the tool itself. A table scan in Oracle is when the Oracle server has to scan the data or index page to find the appropriate record. The reason you would want to find and fix your scan is because they generally require more I/O and also take longer time to process. This is something you will notice with an application that grows over time. So when it is first released, performance would be great, but over time, when more and more data are added, the index can take longer and longer to complete. So tracking physical and logical read along with buffer cache hit will help you to identify performance bottleneck. Similarly, we have option where you can pull out the wait time and corresponding event of a session. You can track account status and user expiry information for the users that has been created to access those sessions. And again coming to the SQL Server for waiting, a resource wait is accumulated by processes running on SQL Server, which are waiting for a specific resource to become available, such as waiting for the release of a lock on a specific record. The promise of wait stat is to quickly identify where the most pressing bottlenecks are building within SQL Server. Resource waits are further broken down into 100 of specific categories. The exact number varies by version of SQL Server. These categories called wait types, which enables you to determine a more specific bottleneck on a SQL Server, such as schema locking, planned cache memory pressure, backup IO problem, etc. So the promise of wait stat analysis is that now you have excellent way to quickly determine where the stronger pressure point are building upon SQL Server. Now, for example, we have the page IO latch underscore share sh, which occurs when a task is waiting on a latch for buffer that is an IO request. The latch is in share mode. Long wait may indicate problems with the disk subsystem. So it is important that we need to monitor the different wait types, and it will vary from SQL Server to SQL Server. Likewise, it is important to monitor the most blocked queries. The reason is imposing the lock over an object will cause any other process that imposes a request against the locked object to wait until the lock is removed, which will delay execution of that process. The state when a transaction is waiting for the lock to be removed or stopped is what is known as blocking. SQL Server is designed to work this way, and as such, blocks are not inherently problematic. Therefore, only when a high level of block is detected on SQL Server, or in a case in which blocks occur that require excessive amount of time to be resolved, should be treated as potential issue. Identifying such queries will help in increasing log for the next queries or next process to execute. Logs are mechanisms that prevent destructive interaction between transactions accessing the same resources. The database maintains several different types of logs depending on the operation that require the log. In general, the database uses two types of log. Exclusive log, only one exclusive log can be obtained on a resource such as a row or a table, and the second one is shared logs. Many shared logs can be obtained on a single resources. So block time session is one of the important metrics that one needs to be monitored. So let me switch to the product presentation and show you the metrics that we have for the MS SQL and Oracle database in terms of the performance metric. So here we are going to discuss first about sessions. So under session, as you can see, we are showing you the connection stats, SQL statistics, along with various metrics like batch requests per minute. We have the host information, the host connected to the SQL Server, the number of connection in the host, the memory and CPU time used by those server. Likewise, we have the session information that are displayed. And under session, we are going to show you the queries that are getting executed or the process ID. So if we expand this process ID, we will be able to see the query that are getting executed. For example, let me click on the process ID 51, and this will show us the query that is getting executed. And if this query shows as blocked here, we'll be able to kill the process directly from here. Similarly, we have an option where you can filter it out using using session or session lock or block session. So this will help you to identify if there are any process ID that are still running at the background, and then it is possible from the tool to kill that process. Or if you want to do it manually, you can also do it. Now, coming to the performance tab of SQL Server, we have top wait by waiting task. So here we are showing you the top wait filtered by the waiting task of metric. So page IO latch. Likewise, we have log m_x. Likewise, we have page IO latch for. So there are a lot of other wait types available that can be shown here based upon the waiting task. So we can able to associate a threshold or action for these metrics to identify if there is a problem in the wait types. Likewise, we have most block queries. So in case if you want to understand the query which are getting blocked, we will be able to understand the query and the total time blocked or average time it got blocked along with the database name. So along with the database name will help you to identify, okay, those are the database which the application team uses, or some other application or some other team are using that database. So it will be helpful for you to troubleshoot those matrices. In the Oracle database, we have table scan. So where table space data will be shown along with the used byte, free byte, and percentage of used byte, etc. So these metrics will help you to keep a tab on how the table space is working properly or being accessed properly or not. So if there are times where you need to pump up the resource, so based upon the threshold that you have defined, you will be able to monitor that. Likewise, in session, we have various sessions that we show here that are running in the machine, along with the elapsed time and table scan information. So physical read, logical read, and buffer cache hit ratio in this tab are important to monitor. Now, there are other attributes as well in the Oracle database as well as in the SQL Server database, but those are pertaining to the database administrator. Those are again important, but those are in terms of database server. So if one can identify these matrices with flawlessly, you can able to improve your application performance if it needs to be fine-tuned. Or if it is a database server which is causing the issue, you will be, with the help of these metrics, you will be able to troubleshoot your application along with your database administrator. Now, let me switch back to the presentation and let's discuss on the next topic, which is again an important one, to analyze the error trace to eliminate any performance issues or performance related traces that we encounter. So we can able to identify the internal invocation method in code and trace that execution detail in the URL or the URL address that has been accessed. Now, similarly, we can drill down to the summary of what is the slowest component and the time it took to execute, and drill down to the trace information, like which method has caused the problem, or which query is taking more time to execute. So we can drill down to the method and the subqueries. And if we want to identify the exact query that are getting executed, we can click on the SQL statement tab and get those SQL statement again, along with the execution time. So this will help us to analyze the code, the flow, and along with that, the SQL queries that are getting executed. So if the SQL query has to be fine-tuned, the respective DevOps team can fine-tune the query so that the performance bottleneck is rectified. Similarly, apart from the web transaction, most application runs background tasks to perform various tasks like maintenance, scheduler, messaging, etc. So APM Insight also capture these transactions and list them under background tab in APM Insight Dashboard. And along with that, we can able to pinpoint the exact errors that has happened in the web application. So for instance, you accessed a web application, you are getting an internal page error or some other bad gateway error. We'll be able to capture those errors here and we'll show you the exact stack trace where that issue has occurred. And along with the stack trace, we'll also show you the Java code line in case you are monitoring the Java-based application, and you will be able to troubleshoot. So exception here means it's an event which occurs during the execution of a program that disrupts the normal flow of a program instruction. So exceptions are used to indicate many different type of error condition across all the application layer. For example, out of memory, internal server error, bad gateway error, IO problem, null pointer exception, etc. So these are all various errors that you may encounter, and capturing this error along with the information about where the flow is will help you to understand the problem in your applications. So this could indicate system problem, or this could also indicate a logical problem. We can able to identify that. So let me switch to the product presentation and show you the various attributes. Let me close this SQL Server and application, Oracle Server. Let me go to the APM Insight tab. Let me click on the My Application, and we are able to see the dashboard. Now, if I scroll down, I have this recent file transaction, recent error transaction, and reset transaction by response time. So there are three widgets that we are showing in the Overview tab. So in the Overview tab, we will be able to understand, say for example, let's take this recent file error. And I'm going to click on the first error in a web page. So this will take us to the error tab, the last one. And from here, we will be able to understand the method that had an error, the trace information, the SQL statement that are getting executed, and the stack trace. This is an important one where we can able to show you the exact line number where the error is. So here we have a web application. A sample web application, so I can sign in log in, and let's say I'm generating an error. So this error will be captured in the application manager. So the APM Insight agent will collect this data and push it. Once the data is collected, we'll show you the stack trace. You can drill down to the code level and analyze the flow along with the method, SQL statement, and stack trace. So this will help you to identify if there are any performance bottleneck in any application. Likewise, let's assume that you want to check for other web application. So the one which I showed you under overview, it is the recent transaction. But what about the previous transaction that has happened a few minutes ago? So under web transaction tab, we have an option where we show all the web pages that were accessed recently, and we have an option where we can click on the index, the web transaction that has happened, and on the right hand side we show you the component split up. And here, as per the image, we can see the structs is taking around 88% of the resource. And if we want to drill down to the trace of this detail, we can click on the trace of this transaction, and this will take us to the traces tab. For that particular web transaction, what are all the different traces we have, we can able to see it. So under trace tab, we'll show you the summary of which component was accessed, the trace information, and the SQL statement which are getting executed. And not only that, under database tab, we are going to show you the exact query. Not only that, we are going to show you the method name in which that query was used. So this will again help you to identify and troubleshoot the performance issue. Now, let me switch back to the presentation. So the APM Insight agent instrument predefined classes of several web components and framework to provide insight in the application. So APM Insight also provide an option to custom instrument classes of your choice. Custom instrumentation helps in providing wider insight into your application, where it will be easier to track performance of specific feature or module in the applications. So with this, let's discuss about the JVM, which is one of the important metric that needs to be monitored for any Java application. So this JVM tab will not be available for .NET based application. So JVM is an abstract computing machine that enables a computer to run a Java program. And it is important to keep tab on metrics such as JVM CPU usage, heap and non-heap memory, thread information. So these are few important metrics that one should need to be monitored for any for application to work flawlessly. So garbage collection make Java memory efficient because the garbage collector remove the unreferenced object from the heap memory. Similarly, Java application in production can have hundreds of threads running in a parallel. When an issue is detected, example, Java is taking a very high CPU resource, an obvious question which thread is causing the CPU spike, and an immediate next question in which code snippet is the thread executing. While it is important to report this information in real time, it is also important that these details are made available for historical analysis. So now we are at the end of the session, but before that I want to show you a few metrics of the Java runtime monitor. So for this, let me go back to the product presentation. Let me click on the monitors tab and go to the Java runtime monitor page. So in order to identify or drill down in-depth analysis of your Java your thread, we can add it as a Java runtime monitor in Applications Manager. So here we are showing you the connection time, memory usage, CPU usage, the system information, process detail, heap memory, non-heap memory information. Not only that, we have other tabs like garbage collection, thread information. So under thread tab, we are going to show you the total thread, block thread, runnable, waiting, etc. Based on that, we can create a threshold and associate an action to notify the end user. Not only this, we can generate the thread dump, and we can check which process or which method is taking more CPU time or more memory, and based on that we can able to troubleshoot the information. So with the information like user times, CPU time, block or waiting, we can able to drill down to the thread name. Even we can click on the thread information and it is going to show us the exact query or the method or the line number where there is a problem. So we can able to understand effectively where the problem lies. So let me close this window and go back to my presentation. So we are now at the end of the session, and after the recap of what we have seen today, we are going to have our question and answer session where there are a lot of interesting questions raised during the webinar, and we are going to answer that question as well. So we started with the importance on how it is required to monitor the response time and user satisfaction. You can even identify the slow transactions that are slowing down your app along with the database query that are running at the background. How it is important to analyze error traces to eliminate any performance issue in the application. Along with that, we have also seen few metrics, important metrics that a database server needs to be monitored.